What's up, everybody? Patrick here, moving on to another example with polynomial inequality. So if f of x is equal to 2x to the power 4 minus 24x cubed plus 2x squared plus 80x, and g of x is 10x to the power 4 minus 12x squared plus 20x, when is f of x less than or equal to g of x? Well, notice this is just going to be an inequality, right? They're asking us, when is f of x less than or equal to g of x? So we got these two functions here. Well, we can just simply plug these functions into this inequality, right? So f of x, the left side, is going to be all of that there. So 2x to the power 4 minus 24x cubed plus 2x squared plus 80x. When is that less than or equal to g of x, which is just this polynomial here? 10x to the 4 minus 12x squared plus 20x. So now at this point, just like we did before, we have to solve this polynomial inequality. So the first step is we want to take everything, bring it over to one side. So I'm going to take everything on the right side, bring it over to the left. So I'm going to rewrite the left side here, 2x4 minus 24x cubed plus 2x squared plus 80x. This 10x to the power 4 comes over, that becomes negative 10x to the power 4. This comes over, becomes positive 12x squared, and then this positive 20x becomes negative 20x. And notice how there's now a 0 left on the right side. So let's collect some like terms here and simplify. Notice this 2x to the power 4, this minus 10x to the 4, those go together, so that's negative 8x to the 4. Negative 24x cubed, that's actually just by itself, so we can rewrite that. And then we have this 2x squared and 12x squared, so when we add those, that becomes positive 14x squared. And then 80x minus 20x, that becomes positive 60x. And we're finding when is it less than or equal to 0. So we basically took that problem and simplified it down to just a polynomial inequality. Negative 8x to the power 4 minus 24x cubed plus 14x squared plus 60x less than or equal to 0. So now what we have to do is we have to take this left side and we have to factor it. And notice how we have a degree of 4 here. So we're going to have to go through a bunch of factor theorem and a bunch of long division. First thing you want to check though, can you take anything out? Well, notice negative 8, negative 24, 14, 60. We could take out a 2. And I actually recommend taking out a negative 2 to make that leading coefficient positive. So we'll take out a negative 2. Notice how we can also take out an x, because there's this 60x here. We got x squared, x cubed, x to the power 4. There's no constant here. So we can actually take out a negative 2x from everything. And when we do, negative 8x to the 4 divided by negative 2x, that's just positive 4x cubed. Right? If we take out negative 2x from negative 24x cubed, that gives us positive 12x squared. If you don't want to do that mental math, what you can do is you could take each of these and then just divide it by this negative 2x that we are taking out. Right? Negative 24 divided by negative 2 is 12, and then x squared left, right? So 14x squared. If we take out a negative 2x, what happens? 14 divided by negative 2 is negative 7, and we're left with an x at the top, right? There's two x's at the top here, so we got like x, and then we have one x at the bottom, so that means we have one left at the top. So this would be minus 7x, and then we got 60x divided by negative 2x. That would simplify to negative 30. The x's would cancel out. Right, so we'd be left with minus 30 over here. And this is still less than or equal to 0. So at this point, we're still dealing with a cubic function, right? But notice how it's a lot easier to deal with this cubic function than it is dealing with this quartic function up here, right? After we take out this negative 2x. So what's remaining to factor is this cubic. So let's label that cubic function as f of x down here. So we got 4x cubed plus 12x squared minus 7x minus 30. Right, so what we're going to have to do is we're going to have to apply factor theorem. So we're going to have to try a bunch of different factors. So we're going to have to plug in like 1 for x, negative 1, positive 2, negative 2, etc., etc., right? Keep going down until we find something that makes it equal to 0. So when we plug in these for the x values, we get these respective y values. And notice when we plug in negative 2 for the x values here, we get 0. So what that means is that x plus 2 is a factor by the factor theorem, right? So what we have to do now is we have to take x plus 2 and see how many times it divides into this polynomial, 4x cubed plus 12x squared minus 7x minus 30. And when you do that long division, you end up getting this quotient here, 4x squared plus 4x minus 15. Remainder should be 0, right? Because x plus 2 is a factor. So let's erase all this here, and then let's continue on with our polynomial inequality here. So we'd have negative 2x, and now we took this polynomial, split it up into this divisor, x plus 2, and then that quotient, 4x squared plus 4x minus 15. And we're still finding when is it less than or equal to 0. So now all we have to do is we have to factor this quadratic here. And if we factor that quadratic, we end up getting 2x plus 5, 2x minus 3. So notice now that we took this polynomial on the left side, fully factored it into negative 2x, x plus 2, 2x plus 5, 2x minus 3, and we have to find when is that less than or equal to 0. Now in the overview video, I showed you 2 methods to do that, by graphing and with a sign chart, and we're going to go over both methods. So first method, let's do it by graphing. So how would we graph this polynomial? Let's graph it over here. Well, first thing is degree is 4, it's an even degree, and it has a negative leading coefficient. So you want to look for that in the expanded form. You don't want to look for that in the factored form, right? It's going to take you a lot more work, take all the leading coefficients, multiply them out. It's easier to just see here. Leading coefficient is negative 8, degree is 4. So taking a negative leading coefficient and even degree, we know the end behaviors are going to be from quadrant 3 to quadrant 4. Now, a remark I want to make about this is sometimes you'll actually get inequalities where it's already factored for you. So the question might just look like this, right? You may not have to go through that factoring process. Then if you're doing it by graphing, then you have to manually sort of find the degree, right? 1, 2, 3, 4. And then you have to manually find the leading coefficient. Negative 2 times 1 times 2 times 2, which would give us negative 8. Right? But if it is expanded for you initially, it's easier to get the degree and the leading coefficient from the expanded form. Anyway, so these are the end behaviors. Now, what about the y-intercept? Well, the y-intercept, if we plug in 0 for all the x's, notice that we'll get 0 for y. So it's going to go through the origin. That makes sense because notice how this x here is by itself, so we know one of the x-intercepts is going to be 0. And whenever one of the x-intercepts is 0, the y-intercept is 0 as well. So 0 is one of the x-intercepts. The x-intercept here is going to be negative 2. Here, it's going to be negative 5 over 2, which is the same as negative 2.5. And here it's going to be 3 over 2, which is the same as 1.5. right? So let's put all these in order. So negative 2.5 is here. Then we have negative 2 is next, so let's put that here. And then we got positive 1.5, which is over here. So if we graph this, how's it going to look like? It's going to go something like that, right? So that is an approximate graph for this polynomial. And you don't have to make it too exact. Notice how this is not really to scale the x-axis, etc. The most important things is to get the end behaviors right and to make sure that it goes through those x-intercepts in a correct manner. And now this is just asking us, when is it less than or equal to 0? So they're asking us, when is it below or equal to the x-axis, right? When are those y values less than or equal to 0? When are they negative or equal to 0? Well, notice this graph is going to be below the x-axis here. It's going to be below the x-axis here and over here. So notice how there's 3 intervals. So this interval here happens when x is less than negative 2.5. Let's put it in fractions actually, so negative 5 over 2, right? But we have to put less than or equal to, because they're asking us less than or equal to 0. Notice how it's equal to 0. The y value is equal to 0 at negative 5 over 2, negative 2.5 as well. So we have to make it inclusive. So that's one of the answers. Next answer is that the x value is between, when the x value is between negative 2 and 0, it's below the x-axis. So negative 2 and 0. And then over here, when x is greater than 1.5 or when x is greater than or equal to 3 over 2. Let's keep it in fractions. So notice in this question, there are 3 answers to this inequality. There's 3 intervals where this polynomial is below the x-axis or equal to 0. So now let's go about it the second way. Let's do it with a sign chart, and then let's see if we get the same solution that we got from the first way when we graphed it. So with a sign chart, what do you want to do? You want to first start out by writing negative infinity, like we mentioned in the overview video. And then you want to list out the x-intercepts from lowest to highest. So the lowest of these, negative 2.5. Then it's negative 2. Then we got 0. Then we got 1.5. And then after you list out the x-intercepts, you write out positive infinity at the end. And then you want to draw these columns under each of those. And then we're going to have to make some rows. And the rows are going to depend on the factors. So the first factor is going to be this negative 2x. So let's put that up here. Next factor is going to be what? X plus 2. And then we'll have 2x plus 5. And then we'll have 2x minus 3. And then the last row is just going to be basically the polynomial, basically all of these multiplied together. So what you want to do is you want to take these intervals and you want to pick numbers in between them that we can plug into these factors. So between negative infinity and negative 2.5, let's pick maybe negative 3. So if I plug in negative 3 for all these factors, negative 3 times negative 2, that gives us positive 6. Negative 3 plus 2, negative 1, that's a negative number. This would be a negative 1. That would be a negative number. This would be a negative 9. That would be a negative number as well. Between negative 2.5 and negative 2, let's do negative 2.25. So negative 2.25 times negative 2, that gives us positive 4.5. This would be a negative 2.25 times 2 is negative 4.5 plus 5 gives us positive 0.5. this would be negative. A number in between -2 and 0 is -1. Plug in -1 here. Positive, 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 and negative. Between 0 and 0.5, so like +1, plug it in here. Negative, positive, positive, negative. And then between 1.5 and infinity, so like 2, if we plug in 2 here, negative, that would be positive, positive, and that would be positive as well. So now what we do is we have to take these signs and then multiply them out to see what the sign of the actual polynomial function is going to be in between those intervals. So positive times negative times negative times negative, that would give us a negative. These two negatives make a positive times positive times positive, that is positive. This would end up being negative. These two negatives end up being a positive times positive times positive, that's positive. And then this would be negative. So this last row is what we are concerned with. So when is this polynomial function less than or equal to 0? Well, it's going to be less than or equal to 0 here, right, in between this interval and at -2.5, right, because at -2.5 the function, or rather let's write that 0 down here, the function is going to be 0, right? It's going to be 0 at each of those columns. So where else is this function less than or equal to 0? In this interval here, and then in this interval over here. And notice how these intervals are the same as the intervals that we got when we graphed it, right? From -infinity to -2.5, which is the same as when x is less than or equal to, you know what, that should be -5/2 here. Sorry about that. Right? When x is less than or equal to -5/2, that's the same thing as right here. When x is between -2 and 0, that's this interval here. And then when x is greater than 3/2, which is the same as x being greater than 1.5 or between 1.5 and positive infinity. Now another way you can write these solutions, instead of interval notation, you could write it with set notation as well. So let's do that. So this interval here, we can represent as x is an element from -infinity. Whenever you have -infinity or positive infinity, there's always a circle bracket there, to -2.5 or -5/2. Now this we would put in square brackets because it's inclusive of the -2.5 because of this less than or equal to 0, right? And then this interval here we can write as x is an element between -2 and 0. Again, square brackets because it's inclusive of those values. And then this last one, x is an element from 1.5 or 3/2 to positive infinity. And that there is a circle bracket, right? Whenever you have infinity. So interval notation or set notation, either way works, but the answers to this question we showed in two different ways, with a sign chart and then before with graphing.